Hi there, welcome to this lesson on Pure Mathematics 1. And in this lesson, we're going to have a look at a couple of problems related to the equation of a straight line. Now, in the last couple of lessons, we've learned three different forms for the equation of a straight line. There's what's probably the standard form for the equation of a straight line, y equals mx plus c. And that's useful because if you write the equation in that form, then you can say straight away what the gradient of the line is, that'll be m, and the y-intercept, that'll be c. Rearranging that, sometimes it's preferable to write the equation in the form ax plus by plus c equals 0, where a, b, and c are integers. The reason why that's preferable is really just that it looks slightly neater. But the values of a, b, and c, they don't tell you anything useful about the line in the way that m and c do. And then the third form that we learned was if you know the gradient of the line and you know a point on the line, x1, y1, then y minus the y coordinate will equal the gradient times by x minus the x coordinate. And multiplying that out will give you the equation of the line. Okay, we'll now look at some harder examples. So first of all, the line y equals 2x minus 5 meets the x-axis at the point A. Find the equation of the line with gradient 3/7 that passes through the point A. And then write your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. I'll let you have a go at this yourself first. Pause the video, come back to me when you're ready. Okay, let's have a look at this. So that was the question. Now, y equals 2x minus 5 meets the x-axis at the point A. Well, the line meets the x-axis where y equals 0. The x-axis is frequently called the line y equals 0, which means if we want to know the x value where the line cuts through the x-axis, we just have to substitute y equals 0 into the equation of the line. And that'll give us 0 equals 2x minus 5, which means 2x equals 5, and x equals 5/2. So we now know the coordinates of the point A. The point A will be 5/2, 0. 5/2 because we've just worked it out, and 0 because it's on the x-axis, and y equals 0 on the x-axis. We want to find the equation of the line that passes through that point and has got gradient 3/7. Now, the easiest way to do that is to use the third form for the equation of a line. If you know a point and you know the gradient, then you can just say y minus the y coordinate is equal to the gradient times by x minus the x coordinate. So that'll give us y minus 0 is equal to 3/7 into x minus 5/2. Multiplying out the brackets gives us that. Now, that is y equals mx plus c, so the gradient is 3/7, and minus 15/14 would be the y-intercept for this straight line. But we've been asked to write the answer in the form ax plus by plus c equals 0, where a, b, and c are integers. To change these fractions into integers, the quickest way to do that is to multiply everything by the lowest common multiple of 7 and 14, the numbers on the bottom of the fractions. Well, the lowest common multiple is 14. So if I multiply through by 14, the fractions will go. And I'll get 14y is equal to 6x minus 15. And rearranging that gives me 6x minus 14y minus 15 equals 0, which is the form we were asked to write the equation down in. Okay, example 2. The lines y equals 2x minus 8 and 3y equals x minus 9 intersect at A. The point B has coordinates 7, 1. Find the equation of the line that passes through A and B, and then write your answer in the same form as the last question. Ax plus by plus c equals 0, where a, b, and c are integers. Now, we know one point that the line goes through. We need to calculate the coordinates of the point A, and we'll do that by solving these two equations simultaneously. I'll let you have a go at doing that and completing the question. Pause the video, come back to me when you're ready. Okay, let's have a look at this. So, as we said, we need to find the intersection point of these two lines. We need to find A, and the way we'll do that is by solving the equations of the two lines simultaneously. The easiest way to do that is to substitute equation 2 into equation 1. So taking the value of y from equation 2, y equals 2x minus 8, and substituting that in for y in equation 1. That'll give us 3 times by 2x minus 8 is equal to x minus 9. Multiplying out the brackets will give us that. Tidying things up gives us 5x is 15, which means that x is equal to 3. To find the value of y, the easiest thing to do is to go back to equation 2, because that tells us that y is equal to double x take away 8. 2 times x take away 8 will be 2 3s is 6. 6 take away 8 is minus 2. So x is 3 and y is minus 2 at the point A. So the coordinates of A are 3, minus 2. Now, we know 2 points on the line. We know 3, minus 2 and 7, 1. Probably the easiest way forwards from here is to work out the gradient of the line joining those 2 points together. And that's equal to the change in y divided by the change in x, which is 1 take away minus 2 over 7 take away 3. 1 take away minus 2 is 1 plus 2, which is 3. And 7 take away 3 is 4. So the gradient will be 3 divided by 4. Now we've done that, to find the equation of the line, well, we know 2 points. We know the gradient. The third method for finding the equation of a line needs the gradient, and it just needs 1 point. Now, what that means is we can choose which of these points we use. Doesn't matter which you use. Both of them will give you exactly the same answer. Now, I'm going to choose to use 7, 1 just because it looks slightly easier to choose those 2 values. So y minus y1 becomes y take away 1, the y coordinate, which is equal to the gradient, 3/4, times by x minus x1, which is x minus 7, the x coordinate. Now, I'll multiply through by 4 to deal with this fraction, and that'll give me 4y minus 4 is equal to 3 into x minus 7, multiplying both the left and right-hand sides by 4. Multiplying out the brackets will give me 4y minus 4 is equal to 3x minus 21. Therefore, tidying things up, 3x minus 4y minus 17 equals 0. And that is exactly the form that they asked me to write the answer in. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 92 and have a go at exercise 5D. Thank you very much for listening, and cheerio.